So we'll look here at our example, okay? So we're given some piece of information. MPQ, right, is equal to the measure of MNQ, which is 90 degrees. That's already listed for us here in the picture. MN is congruent to PQ, so we can go ahead and list that too real quick. MN, PQ. And we want to prove the triangle MPQ is congruent to triangle QNM. Okay, so we'll start with our given information. All right, so measure of angle MPQ, right, is equal to the measure of angle MNQ, which is equal to 90 degrees. And segment MN is congruent to segment PQ. And that's all given to us. Okay. Now, since the title of the notes here is hypotenuse leg and CPCTC, then there's a good chance you kind of already know what we're going to be using here. We're going to try and prove these two triangles congruent probably by hypotenuse leg. Okay. Now, to have a hypotenuse in a triangle, what kind of triangle must we be dealing with? Yeah, must be a right triangle. So to use hypotenuse leg, okay, must be a right triangle. Now, just because the triangle is a right triangle does not mean it's going to necessarily be hypotenuse leg. Okay, so let me repeat that, right? Just because the triangle is a right triangle does not necessarily mean it's going to be hypotenuse leg. But you have to use hypotenuse leg, or if it's a hypotenuse leg, it must be a right triangle that you're dealing with, because only right triangles have hypotenuse. And well, only right triangles have hypotenuses, I guess I'll say. Okay. So let's see here. So Melissa, do you see any other congruences that we could list here? We already have one congruence. The MN is congruent to PQ, and we can kind of technically say, I guess, that we have two congruences because we have the 90 degrees. So what's another congruence we could list here? There you go, exactly right. Okay, and what's the reason that we can say that something is congruent to itself? Reflexive property. You got it, Melissa. Good job. Okay, and so we'll mark that as well. All right, so very good there. And so let's see here. What do we have? So we've got this right triangle here, and we got this side of that right triangle congruent to this side of the other right triangle, and then they both share this side. Okay? So if you were to read this like we normally do, right? If this were like if you were like doing this proof in the wild and not on notes, and you didn't already have a hint that is going to be a hypotenuse leg. But if you're just doing this on your own, you might look at this point and see, aha, okay, I have one pair of congruent angles, another pair of congruent sides, and another pair of congruent sides. So I have three pieces of information here. I should be able to say whether these triangles are congruent or not. And then you might look at this and say, okay, well, let's see, which congruence would I use? Well, I see an angle, and then a side, and then a side. And so you might be tempted to say angle, side, side. But you know, right, Mr. Whitmire is like, wait a minute, I shouldn't be writing bad words in my proofs. So maybe this is wrong, okay? But it turns out that angle, side, side is true in a right triangle. Angle, side, side in a right triangle gives you the hypotenuse leg, and that's why we have what we call it hypotenuse leg, though, because it's just the one hypotenuse is congruent to the one leg there. So this is enough. We are actually done. We can actually prove these triangles congruent. And so, Adam, what should be our final statement here? What's the last thing we're going to say? You got it. Or Q and M. There you go, yeah. Okay, yeah, MPQ is congruent to Q and M, and because why? What's our congruence here, Adam? Right, hypotenuse leg. You got it. Hypotenuse leg is it. Okay, and that's it. That's it. Okay. So very good. Any questions on that? Pretty straightforward. That one was like a super easy proof. 3 steps. Boom. I don't think that's much shorter than that. Unless you gave all your congruences and the given information, and then it's only 2 steps, I guess. But okay. So let's look at this next one. All right. So again, we'll start out right with the given information. K, L, is, what does the symbol mean again? Perpendicular, and perpendicular means that the two segments, what? What does it mean for the two segments to be perpendicular? Oh, silence. Okay. What's that? Make a right angle, Lindsay, is that what you're going to say? Yeah, that's right. Thank you. Thank you. Yes, exactly. They meet at a right angle. Yeah, so that's going to be important. Okay. So we've already got one congruence given to us. JK is congruent to KM. Okay, that's one congruence we have there already. Okay, but that's only one congruence. So we need to come up with some more here, right? So let's see here. What's another congruence we can see? Let's go to Maria. Maria, do you see any other things we can mark congruent here in our picture? Or we could then state our congruent over here in our proof. Keep in mind we're trying to prove that that triangle JLK, so this triangle here, is congruent to MLK, this triangle right here. The middle line? Yeah, KL is congruent to what? Yeah, exactly, itself. And what's the reason for that? Reflexive. Okay, good. Alright, so that's two congruences now. So I'll go ahead and mark that. Okay, ideas here, yeah, Michael.
JLK is equivalent to MLK?
So, yeah, and in fact, I'm going to, yeah, exactly. So I'm going to say like something like this. The measure of angle JLK is equal to the measure of angle MLK is equal to 90 degrees. If we're trying to go for hypotenuse leg here, we need to establish that we have right triangles. This perpendicular statement is not enough to really establish that we have right triangles. Or, I mean, you might argue that it is. I guess, I don't know. You know, it kind of depends. That's part of the things with proofs is like how detailed do we need to be in our proofs, you know. But in this case, I think it's a good idea to go ahead and say that these two angles are right angles. So that way it establishes that we have right triangles there. Okay? And so we know that. Well, what's our reason for that? Knowing that, though.
Definition of perpendicular lines.
Yep, you can say definition of perpendicular lines. You can also just reuse the statement KL is perpendicular to JM. That's sufficient as well. Okay. Okay, and then Keegan, what would our last step be here?
Triangle JLK is congruent to triangle MLK.
Yep, you got it. And what's our reason?
Isn't it a HL? Whatever.
Hypotenuse leg.
Hypotenuse leg.
Hypotenuse leg, exactly. HL, yep. We got the hypotenuse is congruent, we have the legs congruent. Okay. There's actually one other congruence here that we could pick out from our shapes and not require HL. Yes, Shannon? So you want to say segment JL is congruent to segment LM. Okay, so what would your reason be for that? So that's a good observation here. When we say, so there's kind of two things we talk about sometimes. We talk about a perpendicular bisector, and we talk about perpendicular, and this is just perpendicular. Okay, so we can't necessarily. I mean, obviously they're going to turn out to be equal because the triangles are congruent, but we can't use perpendicular bisector because it's just perpendicular if we're told. So we can only use that. There is one other thing here that we could. So there's another pair of congruences we can come up with. Okay, and it's like. So let me kind of hint at it this way. So our big, like if we consider this triangle here made up of two smaller triangles, this big triangle, what kind of triangle is this big triangle by its sides? It looks equilateral, but based on the markings, what can we say for sure? We're not sure if it's equilateral, but based on the markings, we can say for sure, but by the sides, it's what? It's isosceles. Isosceles. Okay? Now, since we have an isosceles triangle here, and if these two sides are congruent, that makes angle J and angle M base angles here. How do you think these two base angles are going to be related? They're going to have to be the same as well. Okay, now we haven't seen that theorem yet, so we can't like use it necessarily, but because this is an isosceles triangle, the two base angles, angle J and angle M, will also be congruent. Given that, then we could use angle side as also a possible proof as well. Okay, there's another like justification there because of the way this is designed. So, anyway, but we'll move on there. All right, one more here I want to show you, and this is the this is kind of the introductory proof that I want to use for CPCTC. Okay, so again, CPCTC stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. Okay? And you may use that acronym, so you don't need to write the whole phrase out. Feel free to use that. Okay? You're going to make your hand fall off right now every single time. So, what's the clue here, or what clues us into the fact that this is a CPCTC proof? Well, look here in the information that we typically look, they typically kind of like proof information here. What is different about this kind of information than what we normally have seen so far? Yeah, Hunter.
It doesn't try to make an angle measurement or something like that.
Okay, that's true. In the given information, it doesn't tell you like an angle measurement or something like that. I'm looking more specifically at what we're trying to prove. What's different about what we're trying to prove here?
Oh,
To what? Go ahead.
2 lines over.
Yeah, 2 segments. Every other proof that we've done so far in this little section, what are we trying to prove, Hunter?
That on AB is congruent to on CD.
Well, I'm talking about every other proof that we've done so far. What are we trying to prove? Yeah, triangles are congruent. Here, we're just trying to prove 2 pieces. AB is part of the lower triangle, CD is part of this upper triangle, right? So how can we go about doing that? That's what clues us in, is that these 2 sides, they're corresponding parts. AB corresponds to CD in the other triangle. So if we can show that these 2 triangles are congruent, then we can add one more additional step and say, since these 2 triangles are congruent, AB must be congruent to CD because corresponding parts of congruent triangles are congruent. So the proof methodology is the same, where we just need to add one more step onto the end after proving the triangle is congruent. So like after we got to here, we'd add one more step on saying, and by the way, AB then must be congruent to CD because CPCTC. Okay? So it's the same principles here. So let's mark some stuff in. So let's see, AB, what does this symbol mean? Parallel. So AB is parallel to CD. Okay? And then BC is parallel to AD. I'll go ahead and write that in here for my given. Okay. All right, so Lindsay, do you see any congruences you can come up with based on that information or something else you see in the picture there?
Line segment BD is congruent
Yeah.
to line segment DC.
Okay, yep. Or you can just list, you can say BD again either way, but we'll go with what you said there. So BD is congruent to DB, line segment BD is congruent to line segment DB. And that's again, the reflexive property, right? Okay. So you got that. Boom. Congruent. What else, though? What other congruences can we come up with here? So, Tanner, what do you say?
Angle ADB is congruent to CDB.
Aha! Okay, so yes, I think we saw one like this yesterday, right, where we had like parallel lines. Did we? Yes, no? Congruent? No? Maybe? Okay. So, I don't remember, but, because I'm getting my merit and honors classes mixed up now, but we have parallel lines here, parallel line BC and AD. I'm going to block off these two, and they're cut by this transversal BD. Okay, that creates alternate interior angles here, and since we have parallel lines, we know those alternate interior angles must be congruent, and so Tanner was exactly right. So angle CBD is congruent to angle ABD. Okay, because I'm going to abbreviate here, so alt int angles are congruent. Oops, and I'm off the screen there. So I just use the angle symbol and then an S next to it to write the word angles, okay? Okay, great. That's right, we need one more congruence though, to show the two triangles congruent. And let me kind of give you a hint. If I turn my paper, okay, about 90 degrees here, and then I block off these two sides, I have another pair of parallel lines crossed by a transversal. And that creates alternate interior angles here. And since these two lines are parallel, these two angles must also be congruent. Okay? So let's see here. So Mary, can you name those two other pairs of angles that are going to be congruent, or the other pair of angles that will be congruent? Oop, and I think I made a mistake here. CBD, and it should be BDA here. I wrote down the wrong order here for this first one. Sorry about that. So it's CBD, BDA. Yeah, sorry. Okay. So now, if you wouldn't mind naming them correctly for me.
Okay. Angle ABD is congruent to angle CDB.
Yeah, very good, right? It's a oof. There we go. We got it. No problem. And again, same reason, right? Alternate interior angles are congruent. Okay. So we got 3 pieces of information. All right, we got 3 pieces of information. So Mason, what can we now say is true?
That line segment AB is congruent to line segment CD.
Well, close. We have to first establish that the triangles are congruent. We have enough congruences to show the triangle is congruent, but we have to actually state it now. So let's go ahead and state that. So it's going to be triangle, name me a triangle there.
Triangle ABD.
ABD. Now, Mason he's free to name that first triangle however he wants. ABD, DBA, ADB, whatever. But now that he's named it that way, he's got to make sure that the second triangle, okay, corresponding parts. So for example, since Mason started with A, for the other triangle, Mason has to start with what letter there, Mason? C, okay? And he went from A to B, so from C he's got to go to D, and then from D to, there you go. Very good. And what congruence are we using here, Mason? Is it hypotenuse leg? Do we have right triangles here?
No.
Yeah, no, it's not hypotenuse leg. What do we see? I have an angle, a side, and an angle congruent to an angle, a side, and an angle. So what is it? ASA. Angle, side, angle. Okay, so these CPCTC proofs are a little bit tough because you have to name the triangles now. You have to, still come up with that congruence. And so now we finally established those 2 triangles to be congruent. Julie, what's our last step? What can we now say?
AB is congruent to CD.
You got it. Okay, and the reason for that is? You got it. CPCTC. Okay, corresponding parts of congruent triangles are congruent. Since these 2 triangles are congruent, AB must be congruent to CD. AB, the first 2 letters there, must be congruent to CD, the first 2 letters there as well, the 2 sides. Okay? Questions on any of that? All right. So then, if there are no questions, what I'd like you guys to do is to flip over to the back and try any 2. Pick any 2 you would like to try on your own, okay? Once you get those done and you feel pretty confident, you can let me know. I'll come around and take a look at it, and then I'll give you the homework assignment. You can get started on that. Okay. So, and if you wish to work together at this point, you may do so. Okay. Yeah.